Okay, hello everyone. In this video, let's discuss the LeetCode problem 242 valid anagram. So the problem shares a given two strings S and T. We have to return true if T is an anagram of S and false otherwise. So the first thing we can let's do is discuss what's an anagram. So anagrams are basically two or more strings that have the same frequency of letters in it. So, for example, if we take up the word anagram and Nechi Arayam, so in this case, you can see that A appears not once. So A appears one, two, three times, uh, and over here is also. So there should be another A here. I'm sorry. So here as well A appears three times. So one, two, three times. So if we check N, so N appears once and N appears once again, and here as well N appears twice. So if we do this for all the other letters as well, so they appear. The frequency of the letters is the same in both the strings. So that's essentially what an anagram is. So we need to check if the two given strings are anagrams, and if they are, we return true. Else we return false. Simple. Okay. So there are a couple of approaches to do this. So mm, let's explore both of them. So the first one is using hash map. Hash map is just your dictionary. So okay, so basically what we're going to do is keep two dictionaries, one for S and the other one for T. So for the string S, we would have no dictionary. Just make it like this, and for T, we have another dictionary. So uh, I think let's take up a simpler example, right? So I'll take S as A, A, B, C, and take T as B, A, C, A. So they have two A's, B and C. Yes, now this is a better example. So now basically what we have to do is we just need to store the letter along with the counts for S in this S hash map. Um, so we can do it as a two. I'll show it in the code, but let us first try run it here. C1 and here as well. So we can make it B would be one, A would be two, and C would be one. So these are the two hash maps, and now all you have to do is kind of check if both of them are equal. So if we name it as h underscore s and h underscore t, so in Python you can just check if h underscore s equal to h underscore t, then return true because they are anagrams. Else, you know, uh, one of the letters might be different somewhere, so or it may have lesser or more frequency, so we return false. That case, for example, if we had uh, instead of yeah, if you had under a here, so this instead of two, it would have been three. So B matches both; they're equal. C also matches, but A doesn't match. So here it's two appears twice, and here it appears thrice. So they would not be anagrams. So this is the first method. So here the time complexity would be we go of, we go of 2n because we first or I mean no, you can do it in two ways. So you can iterate over s once and do all the um, you know frequency calculations, and then you can iterate over t and do the frequency calculations, or you can just use one loop and store the frequencies for both of them at once. So maybe go of n if you use one loop, and space complexity would be big O of um, let's say, yeah, it would be 2m or 2n. Let's keep it as 2n, where n is the length of the largest string. So this is approximately equal to O of n. Okay, now can we optimize? So question is please. Yes. So and it's a really simple optimization. So all you have to do is, if you observe carefully, right? So if we take the example here, so of s equal to a, b, c, t equal to, so this was just an addition which I added as another test case. So if we take it as b, a, c, a, c, a, if we sort s, right? So let me just sort s. So in this case, S would remain A, B, C, and if I sort T, it would become A, B, C. This would be equal to T. So as you can see here, right? So um, the string S, so the string is equal to string T, and this only happens when they're anagrams. So in the sorted order, anagrams would make up the same string, and suppose if we had another C here, okay, and when we sort it, the string S would not be equal to the string C, string T, sorry. So they would not be anagrams. So in this case, the time complexity would be big O of log n, or no, okay, just big O of just be big O of n, because I mean after we sort it, all you have to do is just one comparison to check if no they're equal or not. So it's just big O of n, and space complexity be big O of 1. Yeah. So as you can see, we have improved the time complexity from O of n to O of log n, and space complexity from approximately O of 2n here to O of 1. So it's optimized space and time complexity. Now let's go on to the code. So in the code, you can see it's really simple. So the first thing we do is check if the lengths of both are equal. So obviously, right, if the lengths are different, then they won't be anagrams. Uh, and after that, we keep two hash maps. So one for count s, the one for count t, and then we iterate over either one of them. So here we're iterating over s. So then what we do is fill in the hash map for both s and t based on the letter and its frequency, and then finally we return if count is equal to count t or not. If it's not equal, then they're not hash maps and this returns false, and if it's equal, then it returns true. So I think I might have already submitted it once. Let us check. Okay. It's not loading for some reason, so probably, yeah. So okay, so now we can see that it beats around 59.77%, and And the other way you can do it using sorting is just return sorted of s equal to sorted of t. So this is the other way you can do it. So I think I should run. Yeah, so you can see that it ran, and this is much better. So it's better than 96.18% of the solutions. And yeah, that's all for this video. I'll see you in the next one. Bye.